Hi ladies and gentlemen, this is Mr. Green. This is another in my Algebra 2 recordings, and we're continuing on with our work on conics. So we're looking at Unit 7, we're looking at conics. Don't forget you still have some study island work out there, so make certain you get that taken care of. So, due dates. Want to make certain you get everything done before the due date so that you don't have any zeros in your grade book. We're looking at ellipses today. This is the general formula for an ellipse. You notice how it says ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Note all these signs are the same. They're all positive numbers. Okay, you're not going to see any negative numbers in the ellipses here. Okay, they're all going to be positive numbers. C and A are always going to be non-zero, meaning that there's always going to be an x squared and a y squared term in this. Okay, and uh, it's always going to end is equal to 0. Okay, that is the equation for a ellipse. Now, I want to just let you know that this is the general equation up here, but it is not the graphing form of the equation. The graphing form of the equation looks a little bit different. The graphing form of the equation looks like x minus h quantity squared plus y minus k quantity squared is equal to 1 and divided by a squared divided by b squared. Now this would be a horizontal ellipse, okay? The reason I'm saying that is typically a squared is the bigger number, and the bigger number underneath the x terms means that it's horizontal. If the bigger number is underneath the y squared terms over here, then it would be a vertical ellipse. But this is the one that we would use to graph with. This, when expanded, turns into this equation up here. Okay? So let's go ahead and look at some of these. What we're looking at with an ellipse is the set of all points in a plane such that the sum of the distances from two fixed points called foci is consistent. So that means I've got these 2 points right here, foci, and the distances between them will always be the same. I can take a string, attach it to these 2 foci here, put a pencil here, and draw, and it will go all the way around, and you would get a ellipse. Okay? Now, some things you need to know about an ellipse. If you draw a line across an ellipse from one edge to the other edge, you get what they call the major axis. On that major axis, you've got the center, you've got 2 foci, these 2 points that we just talked about. You also have 2 places where the major axis and the ellipse intersect. Those are called vertexes. The other way, you've got a perpendicular line that goes through the center that has what we call co-vertexes. Okay? That's the minor ellipse going that way. Now, moving forward, if you look at these in general, that a squared that we were talking about down here, this a squared, this a distance here is from the vertex to the center. That's what a is. And so it's real easy to use this a squared, take the square root of it, and you can go from the center and count out to the edge of the circle, to the ellipse. Okay? And then this b squared, you do the same thing, counting in the other direction, either up or down. And that's where you can get those 4 points real easily located. Okay? So how do you find the c, the distance to the foci? Well, there's an equation that we can use to find that c. Okay? It's going to be this one right here. It's going to say c squared is equal to a squared minus b squared. And so we've already got in the equation for it the a squared and the b squared. We just subtract the two, and that'll tell us what c squared is. Okay? So, real easy to do. Let's see if we can't do some of these. This one is asking what the lengths of the major and the minor axes are. Well, the major axis in this one is going to start up here and go all the way down to this point down here. Why do I say that? Because that's the long direction, okay? The x's are both minus 5's in both situations, so it's going from minus 5 to 9. So my length of my major axis, and that's going to be 2 times a, is going to be 14. So a is going to be equal to 7. Okay? The minor axis will be the one going across this way, and our distance there is 4. And so 2 times b is going to be equal to 4, so b is going to be equal to 2. The center, well, that's right here. That's where the two axes intersect. And my axes intersect at minus 5, comma 2 is my center. So I could actually write this equation if we wanted to here for this ellipse. How could I do that? Bx plus 5 squared plus y minus 2 squared. Okay? It is a vertical ellipse, so my a is going to go underneath the y's over here. So since that's 7, 7 squared is 49. And since b is 2, that'll be a 4. And this will be equal to 1. That is my equation for that ellipse. Okay? Looking at this ellipse, it says write the equation and graphing form of this ellipse. Doing the exact same thing. I'm going to look at the major axis going down this direction. And I can see that it goes from negative 14 to a positive 2. So my 2 times a is equal to 16. A is equal to 8. My minor axis goes across this way. And it goes from 8 to negative 2. So 2 times b is going to be equal to 10. So b is going to be equal to 5. My center is going to be located at 5, comma, negative 6. So my equation is going to be x minus 5 quantity squared, and then plus y plus 6 quantity squared. Going to be equal to 1. I'm going to have something in the denominators here. Now, since it's a vertical axis, my major axis is going up and down. I'm going to take 8 squared, 64. B is going to be 5 squared, 25. Now, why did I put the 64 over here? It goes underneath the y's because that's where the major axis is. It's going up and down. Instead of putting it underneath the x's, that's where the minor axis would go. If it was a horizontal one, they would have the 64 would have gone in the other direction. See, this one's got a bigger number underneath the x's. That tells me it's a horizontal ellipse. Okay? So let's look at this. My a in this situation is going to be 9. My b is going to be 4. How did I get that? Square root of 81. That's what 9 is. Square root of 16 is 4. Okay? 2a will be 18, and 2b will be 8. Okay? So let's look at where our center is located. Our center is located at 1, comma, negative 7. So let's go to 1, negative 7. 1, 2, 3, 4, 5, 6, 7. There's my center. Okay? And so major axis is 9. I'm going to count 9 to the right and put a point here at 10. And 9 to the left and put a point. And those are going to be my vertexes. And then I'm going to count 4 up. 1, 2, 3, 4. And 4 down. 1, 2, 3, 4. And there's where my covertexes are. So that means I'm going to be coming from here up to about there, coming back down to here. I draw better ellipses than I do circles. There's my ellipse. That's what the equation gives me. Okay? Okay. Now this term, electricity, eccentricity, it's telling you how how collapsible the ellipse is. Okay, what you're going to do is you're going to take c divided by a. Remember what we did to find c? We said that a squared minus b squared is equal to c squared. Okay, that's what you've got to do to find that c, and then you just divide it by the bigger number. So let's look at an example. Here we've got an equation. My a squared is 25, so a is going to be 5. Okay, my b squared is equal to 4, so b is going to be equal to 2. So I'm going to find the coordinates of the foci. Okay, well, to do that, I've got to find c. That means I'm going to take 25 minus 4, and that's going to be 21, and that's going to be equal to c squared. So c is going to be equal to the square root of 21. Okay, so now that we know what c is going to be located, our center is located at minus 3, 5, and so our foci are going to be located at minus 3 plus or minus the square root of 21, comma 5. Now why did I do it that way? Why did I add it onto the x value and not onto the y value? Because it's only on the major axis that the foci exist. The foci don't exist on the minor axis. They only exist on the major axis. Major axis was the x, and so I added it and subtracted it from that, and that's where my foci would be located. Eccentrically, the e is going to be equal to c square root of 21 divided by 25. I'm sorry, divided by 5, because it's the square root of that. It's just a. So it's the square root of 21 divided by 5. And that's how elastic it is. Okay. Any questions about this? Do not hesitate. Come to the tutoring sessions. Want to talk to you about it. Make certain you understand how these conics are working. Okay. I appreciate you letting me know that you're in Algebra 2 every time, because I've covered conics in my pre-cal class too, and it makes a difference as to how I want to answer your questions sometimes. Okay. So make certain that you tell me that you're in Algebra 2 when you send me K-mails and things like that, so that I can give you the appropriate responses. I look forward to seeing you next time.